specifically. In linguistics, when we talk about correlation, we are dealing with what variables, alphabets, like we all know. So now correlation in linguistics means finding the relationship and see how two or more variables or words, e.g. like vowels, fundamental frequency of words, how they relate together, what's the strength of their relationship, and what's the direction as well. For example, let's say we want to know the correlation or association. Yeah, another word for correlation is association. Let's say we want to know the association between speech rate and the word length. Of course, there's a great, we already know that basically there will be a relationship, or let me say association between the two, because the number of words will determine the rate of your speech. Of course, the longer the words, the let me say the higher the rate, or perhaps depending on how you want to go about it. So also the higher pitch frequency, how high is your pitch responding to shorter vowel durations. So that's what correlation determines for us. Now in statistics, we have majorly two types of correlation. The first one is Pearson, and then the second one is Spearman correlation. How do they different? For Pearson, is normally used when our data set is normally distributed, and then it measures linear relationships. It assumes that the relationship between the variables are linear. For Spearman, it's assumed that the relationships are not linear, and that is used when our data is not normally distributed or when it is ordinal. So mathematically, this is the formula being used for Pearson correlation. And we are not going to that aspect. We are advanced and we are going to our software to determine our correlation rather than using the formula. So how do we interpret correlation coefficients and all of that? Now with this, I'll just go to our practical aspects on this correlation. So in the Google Classroom, there's a practical note, which is on R. We are using R for this practical aspect to run the correlation and the regression as well, which will be taken by Ms. Connie. So I already have mine open. You can, if you have your laptop, you can follow closely, or you just observe while I do that. So this is the R version of the practical.
Hello?
Yes.
So, Edition has been raised.
Yes, ma'am.
And I don't know if it's a mistake or he wants to say something.
Oh, sorry about that. Please, if you want to say anything, just go ahead, because I can't be monitoring the screen and the same in that as well. Edition, please go ahead. Sorry about that.
Okay. Good afternoon. Hello, can you hear me?
Yes, we can.
Yes, I can.
Okay, concerning the correlation, I think you were a little bit fast. I couldn't get what it actually means, like, and how it really relates with linguistic analysis. Please, can you take that once more, please?
Okay. That's fine. So I'll go back to the definition aspect. I started by explaining what correlation is. Can you hear me? Edition, are you there?
Yeah, I can hear you. Yeah, I'm there. I can hear you.
Okay, I said correlation. In other words, you can call it association. Now, from the word correlate, when we say two variables are correlating, it's either they have a relationship in common or they have an association together. For example, let me just go to a layman. Let's say, bread and tea. Do they have a relationship together? Yes, they are correlating because you use your tea. Now, what does correlation do? It measures the strength and direction of between two numerical variables. Do you get that? Now, in linguistic, we don't deal with numerical, isn't it? We deal with vowels, words, alphabet, and all of that. Now, what does correlation mean in linguistic? It helps us to analyze the relationship between one linguistic variable and another. An example of a linguistic variable is vowel duration, the vowel length, the speech rate, word length, paragraph length, characters, and all of that. Do you get that? Now, that's where the correlation comes in. We want to know the correlation or association between speech rate and the length of a particular word. How do you make your speech? How fast will it be based on the length of the words or paragraphs you are having? Is there a correlation between them? The level, what's the strength? What's the strength of the correlation? Do you get it, Edition?
Yeah, I'm
Are you
following.
there? Okay. So do higher pitch frequencies correct vowel durations? Are they corresponding? Are they determining each other? Does it mean that when you have a large vowel durations, your pitch frequency will be low, or will it be high? Or it doesn't really matter if my vowel duration is short and my pitch frequency is that, or are they even correlating? Is there an association or a relationship between them? Am I communicating? Please let me know if you have any issues, just unmute and then talk, please. So, and I mentioned that in statistics we have two different types of correlation, and one is the person and the sperma. The difference between the two is that for the first one, which is a person, we assume linear relationships between the variables we measure. It is used when the data are normally distributed. And for the second one, which is the vice versa, it's assumed that the relationship between these variables are not linear and the data are not normally distributed. Am I good to go from here? Any other question?
Yes.
Edidion,
Continue.
do you get that? Do you get my explanation? What about others? I
Yes,
don't
thank
know
you.
if I'm communicating Lawal, Adedeji, Ganiat, Kasaba, Udo. Please, I need to know if you guys are getting this or not. Can you just
Yes, ma'am.
unmute and let me know?
Yes, ma'am. We're following.
Yes,
I'm
ma'am.
following.
Okay.
We're
All right.
following,
Thank you very
ma'am.
much. So, and I said, all right. Thank you very much. So, mathematically, that's when we were in this. When you want to calculate correlation, use symbolically, or I can say mathematically, correlation is represented with R. That's small letter R. The formula is summation x minus x bar. X for summation of summation is sum, because x the variable and the mean of all the variables. Why? Because we are measuring the relationship between two variables. That's why we have x representing the first variable and the y. But we are not going the mathematical way, because we are in the advanced class where we use our software to determine if two variables are correlated or not. Now, how do we interpret if, for example, the pitch frequency has something to do with the vowel duration of the get? How do we know? And that have the practical aspect in this course. You go to the Google Classroom where the R parts. So I'll be sharing my R screen now. Or can you see? Okay, let me just share my screen so that I can share this with you. All right, so can you see my R interface already?
No, not yet.
Okay, perhaps it's coming up. All right, what about now?
No, not yet.
Please let me see if you can see my screen. Or perhaps I need to reshare. Okay.
Maybe you should share.
All right. I'll do that now. Please just give me a minute, please.
Okay, no problem.
Okay, so can you see my R interface now?
Yes, I can see it now.
All right, thank you very much. What about others? Can you see now?
Yes, ma'am.
Yes, ma'am.
Okay, thank you very much. So to start with, I don't know, just raise your hand if you are familiar with that so that I can know how this aspect.
Well, I'm just getting familiar with it right
All
now.
right.
I don't know about it before now.
All right. So R is just like Python. Is a machine learning software as well. So sort of machine learning, natural language processing, modeling, and all of that. The the software, no matter how it's not as friendly as this, but this is the best, and we call it first R Studio. For R Studio, we, as you can see, the first, that's where all these codes are being entered, and the console pane is where the outputs are being generated, which is the down part of the source pane. And here we have the environment whereby all the history of everything you run it. Whereby if you run any plot or graph code, it gets to show in the plot thing. All right, so to just summarize this, because to start with R, that's another class entirely, but with this, I'm sure you'll be able to cope to some extent. Now, let's say we want to know the correlation or association or relationship or the strength, this, the vowels, and the duration. Three variables actually, the speaker, the vowel, and the create my data set, because I'm not bringing a data set from Excel into R. Now, manually, you can create a data frame in R. And whenever you see hashtag or hash at the end of a word, that means comment. What do I want to do? To create a data set. Now I call data as data. I say data frame is a function. Whenever you see a word being written before a bracket, that's a function. We call it function in R. The first one is speaker. We have 10 speakers. Alphabet A, I, U, A, I, U, A. And then the duration for calling them. And probably able to say that this is the frequency. Let's go. F naught is the pitch frequencies, as you can see, the pitch frequency. Right, so my data vowel duration and F0. Now I want to build the data set. I already compiled this in a data frame and I'm asking how to print. Understand this now, don't worry about it. But make sure to you understand the concept of what I'm trying to do. Now I want to print the data set, which is this. First, let me run this to execute your code in the whole line of codes and then click on run. And then we have this in the console pane. Now the next one, I want to print the data set. Now you can see we have speaker, vowel, the duration, and the pitch frequency in the data frame already. Now I want to look at the correlation between the duration. Let's say this might be now what's the duration and the pitch frequency using the Pearson correlation. In this case, the Pearson correlation assumes linear relationship, and that's where we have this line of code. The function in R to do dot test. So now the linguistic data is here. The dollar sign is used to call the particular variable you want to refer to. The relationship between the duration in the data and the pitch frequency in the data set. So running this code gives this result here. And that's the Pearson correlation result. And the result, and this takes me back to the lecture notes, whereby we have how to man output. And the correlation, you have some major, how do I call it? Let me just say, you have your correlation coefficients, you have your p-values, and all of that. Here now, if your the explanation here is that if your correlation coefficient, there's no correlation, there's no relationship between those variables. And that's what this means, that no correlation. If your correlation coefficient is between 0.1 and 0.3, there is correlation, but the correlation between them is weak. If it's between 0.3 and 0.5, the just moderate. And if it is between 0.5 and 1, then there's a strong correlation between the variables. Now, as this correlation can be positive and it can be negative, that's different directions. As the variable increases, the other one can also increase. That's when we have the positive correlation. And as one increases while the other decreases, that's where the negative correlation comes in.
Sorry, excuse me. Casaba's and
The vowel duration and the fundamental frequency of the. Okay. Asaba, please go ahead. Yes, Asaba, please go ahead.
Okay, thank you very much, Ma. Please, to the previous slide that you were explaining earlier, I saw like if it is 0.5, 0.3 to 0.5, like it is moderate, and if it is from 0.5 to 1, it is strong. So what if it is 0.5 itself? Are we going to categorize it as moderate or strong if it is 0.5? Because 0.5 falls in between those two. Thank you, ma'am.
Okay, thank you very much, Kasama, for that question. Um, let's start from the weak correlation. If you have a value between 0.1 and as between 0.3 and 0.5, although 0.3 is already here as well, and in between 0.3, let's say I have between 3 up to 0.49. That's when the correlation is moderate. That's in between these two values. Do you get? Now the last one in between 0.5 and 1. Those are 0.51, 0.52 up to 0.9. Am I right? 0.09. Something. 0.9, right? That's when the correlation is strong. So those values, do you get that, Kasaba?
Yes, ma'am.
Kasaba, do you understand it? Said we are trying to find the correlation between global duration and fundamental frequency. In correlation as well, there is a hypothesis, but in some cases, the hypotheses are not specifically stated. But there's an hypothesis, although I don't know if you are familiar with what hypothesis means, but it's proven to be true or not. There's null and hypothesis and alternative hypothesis. The null H or something is let me just say a particular fact, a particular statement that is given is true or is as it. Then the alternative hypothesis we say the other way around. Now in null hypothesis, the pitch frequency. The alternative hypothesis will automatically says that there is now hypothesis which says there's no correlation, or the alternative hypothesis that says there is a correlation. This is the code we run in our software, and the value is a very important statistical value that is being used for interpretation to prove if your hypothesis is true or to be rejected. Now let's go back to the from here now, our p-value in this case is 0.2496 for this. Before we go, I'll come back then. 0.2496. And in my lecture notes, it is stated that if p-value is less than 0.05, that means you are going to reject the null hypothesis, which states that there is no correlation between duration hypothesis. Then it means that what there is a correlation that exists between greater than 0.05. 0.05 is a level of significance. In statistics, there was something we call significance level. It can either be 0.05, 0.01. So in this course, we are using the 5% significance level for our interpretation. Now, if the p-value is greater than 0.05 or 5%, we fail to reject. That tells us that there's no significance correlation that exists. Now from our p-value here, our p-value is 0.24. That means this is way higher than 0.05. Then reject this. We don't accept this, but we fail to reject this. This means that there is no correlation, or you can say there is no significant. So I don't know if you have any question before I draw the curtain from here. Do you all understand the practical aspect and both the theory aspect? Okay, so I'll assume we get that. And for the second one here, man correlation method, which assumes that the relationship between the variables are not linear. And if you are to run this, get the output as well. Now, what is our paper? And mind you, in the first year, and that's this. That's 0 minus 0.4. What does that mean? The correlation is negative and it is minus 0.4. Now, answer back to what you asked the other time. When the correlation is negative, that tells us that it has negative correlation as vowel duration increases, the pitch frequency decreases. That's what it means by the negative sign there. Now, 0.4 tells us what? This is in between 0.3 and 0.5. The correlation between these two variables are moderate but negative. We can call it negative moderate correlation or moderate negative as case may be. But the fact is that there's a correlation that exists between the two. The correlation is moderate, but vowel duration increases, the pitch frequency decreases, or vice versa. Now, moving on to the second output, where we have the also is also higher than 0.05, which is our level of significance. In this case, what do? We fail to reject
Sorry.
the null hypothesis. This tells us that
Hello.
there's no correlation.
Hello.
Hello?
Yes. Please.
Is-
I don't get.
Hello, is someone
I don't
talking?
get this part. Yes, I am. Are you saying that we have to use the two tests, both Pearson and Spearman, because Pearson brought a positive value and Spearman brought a negative value. So do we have to use the two to test our hypothesis, or we just stick to one?
You don't, you can just stick to one. And in this case, if you look at it very well, both person, they are saying the same thing. But you can just stick to one. In this case, we are just trying to assume that, yeah, or our data could be non-linear. But in both cases, the correlation is negative but moderate.
Okay,
Did I
thank
answer your
you.
question? All right, you're welcome. All right, so in the absence of just draw the curtain for Miss Only to come in and take the regression part. Thank you very much.
Okay, thank you very much, Miss.
Miss-
Yes, I'm here. Thank you very much. I really appreciate. So, good afternoon once again, class. I'm going to be sharing my screen. Okay, so good afternoon. Let me know if you can see my screen.
Yes, I can see.
Excellent. All right, so I'm going to be taking the regression analysis part, and we'll be fast. We'll do as fast as possible so that we cannot go back because of the electricity issue, which I'm made aware of. All right, so what is regression analysis? How many of us have heard of the word regression before? Please, you can type on the chat box, or you can talk. If you've heard about regression before, what did you know about it? Anybody? Hello?
We are here, man. We are here, man.
Okay, so I'm asking a question. Have you heard of the word regression analysis before? If yes, what have you heard about it? Favor, have you heard of regression analysis? Okay, people are talking.
No, ma'am. I'm not, ma'am.
Okay.
I think
Kasaba, you're saying something.
trying to raise and Lawa Kolawole.
Yes.
Raise his hand.
Okay, ma. I think regression is like a kind of statistical method to predict something, to predict an output based on the input or something like that.
Okay. Kasaba, you want to say something?
Yes, ma'am. I want to say what he said. That's exactly what I
just
wanted to
said.
say. Yes.
Okay, great. All right. So in regression analysis, what we want to do whenever you are saying you want to do a regression, you want to carry out a regression analysis, what you want to do is that you want to estimate the relationship between your dependent variable and your independent variables. So your dependent variable in this case can be called your target variable or your output variable, and your independent variables can be called the predictor or the input variable. Mind you, your independent variable is also tagged as your x's, like x, while your dependent variable is your y, like y, alphabet y. So in simple linear regression, you would have just one dependent variable and one independent variable. But when you're talking about multiple linear regression, then you are talking about one dependent variable, that's one y, and more than one independent variable. That means you have two or more independent variables. That's for multiple linear regression. That's for multiple linear regression, in which I'm going to be showing us the equation. Now, let's go to our material. Material says that, okay, regression measures how one variable predicts another variable. Just like I think Laura Kolawole said, when you're doing regression, what you want to check is, this variable, how is it predicting the other variable? Can we use this variable really to predict this other variable? Is there a relationship between them, a relationship enough for it to predict the other variable? So that's what you are testing. For example, okay, let's assume, I know we are in linguistics and all of us are going to be talking because that's not our field. So, but let's assume you want to how much, you want to predict how much you're spending maybe in a week. You want to predict how much you're spending so that you can now estimate for future and say, oh, that means for 4 weeks I would be spending this so amount. For example, if you are mobile and you want to check how much you're spending on fuel, now that's your dependent variable. And then your independent variable can be, what are the distance that you covered? What is the rate of the fuel you bought at those periods? Now, distance you covered is one independent variable. Maybe the rate of the fuel is another independent variable. Maybe the functions that you went at that time too, at that 1 week, is another independent variable. So they can be, in a real life scenario, you most times don't have just one variable contributing to you don't have one independent variable contributing to your dependent variable. Most times you have more than one, because if you look at it critically, you see that so many things always come together to contribute to one thing in real life. I hope we are getting it. So in linguistic, regression helps to understand causal relationship between variable. What do I mean by causal relationship? What we are saying is that, like, we are assuming that, oh, this independent variable causes the changes in the dependent variable. So that can be your thought pattern when you're hearing regression, especially in this your field of study. That, okay, we want to check, is this independent variable causing changes in our dependent variable? For example, the examples that we have in our lecture notes. Now we have, does vowel duration predict fundamental frequency? And we have, does speech rate predict word length in spontaneous speech? Very good. Now we are here for discussion. Who can explain to us what do we mean by vowel duration? And then who can explain what do we mean by fundamental frequency? Please, let's hurry up. Just give us a better insight so that we ourselves can understand what this terminology means. Anybody? Kasaba, go ahead.
Okay, thank you very much, Ma.
Yeah.
In linguistics, I believe there's correlation between period and frequency, which in this term is duration. So the higher the frequency, the shorter the period, and then the longer the period,
What do you mean by that frequency? What do you mean by that
shorter
frequency? In layman's language, as we are right now, we from statistics are the layman. Explain to us, what do we mean by that fundamental frequency, and what do we mean by duration? Is it like setting time for me to say a word? What do we mean by it?
Fundamental frequency is like the lowest frequency when someone wants to speak, like the lowest rate of frequency, the lowest rate at which the vocal cords start to vibrate or something. So that's the fundamental frequency.
Okay.
So, and
so what about
the higher the frequency now, the shorter the period, because when we are speaking, we tend to speak rapidly. So when the speech is fast, then the time will be short. So, but when the speech is slow, the period, the duration will be long. On that means our frequency will be longer, will be higher when the period is shorter. So that's
okay. So are you saying something like, if I'm whispering, I'll talk faster? Is that what you're saying? Like, if I'm whispering, are you saying the frequency will now be? Do you understand my
largely
question?
we are talking about normal speech. Whispering is another way, another manner of speaking. But on normal speech now, normal speech. So
yeah.
when we're speaking normally, so the way we are speaking faster, then the period in the wavelength, there will be shorter period because we tend to speak fast, tend to speak rapidly. So it will be short.
Okay.
But when we're speaking, when the frequency is slow, when the frequency is lower, then the duration is longer. It's just like when we are trying to reduce the, we are not fast in speaking, then the period will be longer. So that's what they're trying to say.
Okay. Okay. Dr. Peter, sir.
Hello.
Hello, sir.
Hello.
Yes, sir.
Can you hear me?
Hello, we are with you, sir. Yeah, we are with you.
Yeah. Just to add to the conversation. Okay.
Okay.
It's also in science too. So I think what Kasaba is saying is that frequency and period are inversely proportional. So frequency is the number of times an activity happens within a time frame. Duration is the length of the activity. So duration and frequency are inversely proportional. Once duration increases, the number of times it will occur will be reduced. I don't know if that makes sense. Just trying to bridge the gap between between science and arts. All right.
Okay, thank you, sir. I think that just
Okay. I think what Dr. Peter said is something related to what I also wanted to say. Like I want to say
okay.
that fundamental frequency to me is the lowest frequency of a periodic wave form. Why? Because if you look at it in linguistics or speech processing aspect, fundamental frequency can represent the pitch of a voice or sound to me.
Pitch.
Then, in the aspect of duration, you can say that duration is the length or the period of time something lasts. Like, for example, now when you make a speech, like when you are talking or make a sound,
Okay.
you look at it, the duration at which it lasts. So that's duration. Thank you, ma'am.
Okay, thank you very much. I really appreciate it. Yes, we are here to talk about speech rates. We are here to talk about speech rates. Does anybody want to help us with that? Because I know we've talked about that duration, which is what you call period, and then the frequency. Is there any common ground between these two and speech rates? Somebody else I have not talked before. Please, let's rub minds together. We are master students, so we should talk.
Hello, ma'am.
Okay, thank you. Adedeji.
Good afternoon.
I think
Okay,
speech
Eniola,
rate.
Adedeji, please let's listen to Eniola first, then you
Okay.
have it over.
Okay, for the speech rate, it refers to the speed at which a person talks, like how fast is this person saying something. So I think what the question is trying to say is that like the rate at or the speed at which a person speaks, does it predict whether the person is going to talk for long or not, especially because spontaneous speech, I think spontaneous speech refers to I think something that happens, like it just comes, like the way I'm talking, I can't predict, okay, how long am I going to speak? So I think
Yeah.
that's what question, yes. That the speed at which a person speaks, does it predict how long the person would speak for or not?
Okay. Thank you very much. Okay, so Adedeji, please go ahead.
Okay. It's still the same thing now. Okay. Speech rate to me, like what you said is still the duration, I mean the speed or the velocity. You can call it the speed or the velocity at which a person is speaking. For example, now if I'm speaking or I'm trying to pronounce some sound or a word, that's I will check the length, I'll check the speed, the velocity of how the person is speaking. So from there, I can decide that okay, for example, communication. I can decide I can use the rate to identify the kind of syllable, how many syllable occurs in that word. So speech rate refers to the speed or the velocity at which a person speaks in terms of looking at the syllable per second or looking at how the length of the word, the time duration of the word.
Okay. Okay, thank you very much. Yes, so thanks for bringing clarification or clear light to the topic under discussion. So now if we want to check these variables, we have these questions. Does this predict this? And then does speech rate, does it predict word length in spontaneous speech? When you have those kind of questions, you might want to think of a regression analysis. You might want to think of a regression analysis, and we have different type of regression analysis in which I've even mentioned to already. I mentioned simple linear regression and multiple linear regression, and we even have lots more that today's class is not covering. So let me see if I can share a whiteboard. This is our simple linear equation. And if we have multiple linear regression model, as I mentioned, this is how it's going to be. Like, don't forget, this is for simple linear. And I mentioned it earlier that in simple linear, we are going to be having one dependent variable, which is y, and one independent variable, which is x, just one x. But if it is a multiple linear regression that we want to talk about, okay, let me share this tab. Okay, so if it's a multiple linear regression that we want to do, in which I told us that in a real life situation, you are dealing with multiple linear regression. So, okay. Let's erase this. So we are going to be having y equals to beta naught, in which the beta is our intercept. Beta naught is our intercept, in which I'm going to explain to us shortly. Then plus beta 1. In this case, beta 1 will be our slope, beta 1 x1. Now, if we have two independent variables, it's going to be beta naught plus beta 1 x1 plus beta 2 x2, beta 2 x2, then plus e. Now, can somebody help me? If it is three independent variables that we are having, what's it going to be? Hello? If I said
Yes,
if it was...
will be,
Okay, thank you.
yes, it will be beta naught plus beta 1x1 plus beta 2x2 plus beta 3x3 plus e.
Excellent. So I just want us to just have that understanding. Now, the y, just like I've said it countless times today, the y is the dependent variable. And that's the variable you are trying to predict, or you are trying to explain with other variables. And in this case, now, just like from our lecture notes, let's check. From our lecture notes, our dependent variable is our fundamental frequency, and is measured in, I think we call it hertz. Then our x is our independent variable, which is vowel duration in this case, and that's the variable you are using, or that you are using to make predictions. Yes, that's the variable you are using to make predictions. That's our x, or our x's. Then your beta naught is the intercept, or a constant. You can also call it the y-intercept of a regression line. And that intercept, that's the beta naught, represents your predicted values of y. That's your predicted values of your dependent variable when all independent variables are 0. So when your x's are 0, like the example that I said about you buying fuel, how much you spend on fuel in a week, maybe the distance is 0, the rate is 0, everything is 0. So what will the constant be like? That's the beta naught. And for the beta 1, beta 2, up to beta n, that's our slope. And that one measures the effect of y, effect of x on y. That's the slope of the regression line, and it measures like how x change, how y will change with 1 unit of x. So how your dependent variable will change with a change in 1 unit of your independent variable. That's what that measures. And your e is your error term, which at the end of the day, after so many calculations and all of that, is going to be 0. So at the end of the day, you will not really have much to discuss about your e. Now let's go to the next slide. What are the assumptions of linear regression? We have different assumptions of linear regression. I'll just quickly run by those ones. we have the linearity. That means we assume that our variables, the dependent variable, the independent variables, the x and the y, the relationship between them must be linear. We will assume that it must be linear, just like you checked in the correlation. You know, you were checking the level of relationship. Is it positive? Is it negative? That's the direction, and you're checking how well they are associated with each other. But this time around, you are also checking the linearity between them. Are they linear? They must be assumed to be linear. So if they are not linear, then it's either you will use another kind of analysis, and it will not be linear regression, because the assumption of linear regression is that they assume that it is assumed that your variables are linearly related. Then the other assumption is normality, and we can do so many normality tests, and that normality tells us that it shows that, okay, our data is our residuals, that's the error term, follows a normal distribution. Then the next one is homoscedasticity, and that homoscedasticity is talking about the variability of the error, and it is expected for it to be constant. That the variables, the variability of your error term in different levels, when you check it in different levels. For example, let's assume one of your variable is maybe educational level of the respondent or something like that. So it's expected that at every level, the variability of your error term, the variance of it should be constant, so that you can be able to carry out a linear regression. And if at the end of the day you check your homoscedasticity and it is not linear, is not constant, you can try log transformation. We have different ways you can transform your data, in which I'm not sure this class is covering. So you can try log transformation, and then you rerun your test to see if it's now constant. Then lastly, you can also test for your multicollinearity. We have talked about correlation, but this one is multicollinearity. And your x variable should not be highly correlated. Remember that when Mrs. Kafaya was talking about correlation the other time, she was saying that from 0.5 to 1.0, 1.0 it means that it has strong correlation. In fact, 1.0 is called perfectly correlated. So when you have a data set and you run your correlation like that, and you see that the two variables are almost perfectly correlated, maybe you have something like 0.8 or 0.9 or even 1.0, obviously it can't exceed 1.0. So when you're having something like 1.0, it means that the variables are saying the same thing. And if they are saying the same thing, what's the essence of you using both of the variables to predict? So when you want to carry out a linear regression, you have to ensure that your x variables should not be highly correlated. All right, so our lecture note also tells us that when there is violation of such assumptions, yes, I've mentioned it, we may have to do data transformation. Just like I said, you can use log transformation, you can do square root of your data and all of that, or you can even use a different regression model or different analytical tools, as the case may be. All right, so let's go to our example in linear regression in linguistics. The research question is, can vowel duration predict fundamental frequency? So in this case, we have two variables. The first variable is vowel duration, and the second variable is fundamental frequency. Now, can vowel duration predict fundamental frequency? Who can identify the dependent variable here and the independent variable? Can someone identify which one is the dependent variable and which one is the independent variable?
Fundamental frequency is independent variable.
Is
And vowel duration, yes, is independent variable, and vowel duration is the dependent variable.
Okay. Does somebody else want to react to that? Who else want to react to that? Or do we all agree with, I think, Ganiyat? Okay, let's think about it this way. Now, which one is affecting which? Which one is expected from that question? Which one is supposed to affect which one? If you would ask me,
fundamental frequency is meant to affect the duration. So it should be the other way around, actually.
it should be the other way around. Okay, Lawa Kolawole, please go ahead.
Okay, based on the question, Mark, can vowel duration predict fundamental frequency? We are saying fundamental frequency is the dependent variable, while vowel duration is the independent, based on the question there. But I think in the real sense, I think
Based on this question. Okay, so from your linguistic perspective, it should be the other way around, right?
yes, ma.
Okay, so literally speaking, real life, you're saying that fundamental frequency should be the one we are using to predict vowel duration. Is that
Exactly.
right?
Yes, ma'am.
Okay, but for the sake of this class, so that we don't get it mixed up, let's just stick to the lecture material that we have. I hope we won't get it mixed up.
Okay, so this is a question.
Okay.
He's saying, can vowel duration predict fundamental frequency? So from what you are saying no, it should be the other way around. So I think when we run the regression, we'll know. So it's like it's not a statement in that sense. A question: can vowel duration predict fundamental frequency? Because sometimes this causality can be forward and backward. So let's run the regression, and then when we get the summary, we'll know. Go on.
All right, thank you. Okay, so now running the regression in R, I'm going to be sharing my R screen with us, and okay, give me a minute. All right. So Mrs. Kafayat has, can we see my house screen? Sure. Hello, am I alone?
Yeah, yes, ma. Your screen is showing.
Okay, yes, thank you, sir. So I'm not going to re-explain some of these parts since it has been thoroughly taken by the first facilitator. So let's plot the scatter plot of our data set and see. So this line of code, when you see plot, just like it was explained, this plot is a function. So when you see plot, it means that you want to draw in layman's language a scatter plot. And here we saved the old data set as a data frame. We saved it as link data. I'm sure it's linguistic data or something. Now, from there, we use $ duration. Now, what this $ duration means is that from this link data set, because when you print it, you see what you have. You have it like in a tabular form where you have the rows and the columns. So you have 4 different variables: the speaker, the vowel, the duration, and the FO, which is the fundamental frequency. Now, we have the duration. So here we want to pick the duration. But if you just write duration alone, you're going to run into error, because you have to reference the main name, the name you use to save the whole data set. And the same thing happens here. So we want to run duration, want to check duration and FO. Want to plot the scatter plot and see how it's going to turn out. So let's do that. Okay, then this main means that you are saving your chart name as this, This X lab means this will be the X-axis label, and then this will be the Y-axis name. So let's run this. Okay, so can we see this is the scatter plot. Then let's run the model. Now this LM, when you want to run a linear regression, you use LM. It means linear model. So this is the function you use for linear regression. Then your dependent variable, your independent variable follows using tilde sign in between. There is a sign on your system. It's like tilde like this. Then this is your data. If you are not putting this argument, if you are not putting this, you have to write link data $FO link data $duration, and then you are permitted to now remove this. But if you don't want to do that and you just want to write the variable names, that's the column names alone, then you have to write where you are getting those variable names from, and that's this. So let's run the model and then go back to the explanation. Okay, now we've run the model, and this AB line shows the line in the chart. We can see that we now have a line. We now have a blue line because we set it as blue. You can set it as other colors. You just have to type it out as other colors. So we have that. Then we want to convert vowel to a factor. That's this colon called vowel here. We want to convert it, and to convert it, you will have to use as factor to convert it to factor so that we can run the second model. So let's see. Okay, I think there is a line that is missing here. Summary. You know, we have run the first model. Let's talk about the first model before we move to the second. Summary, the model. Let's run this and then see. Okay, so this is what we have. So when we run the question of can vowel duration predict fundamental frequency, FO, this is what we have. And then this is our coefficients, and this is our metrics. Now let's look at this. Let's look at our p-value. We have a 0.2496. We have a 0.2496, and a 0.2496 is showing that it's greater than 0.05. Scafaya told us that 0.05 is what we use for the sake of this study, and even most times in your field of study, use 0.05 for your level of significance. So in this case, your p-value is greater than your level of significance, and by so doing, it means that you are failing to reject your null hypothesis. Now, what is your null hypothesis? That is another question that we need to talk about. Let's go back to our material. Let's go to our material. Okay. Okay. So we have how to interpret the values here. We have that p-value determines the statistical significance, in which we have started explaining. Then the R-square value measures how much variation of fundamental frequency is explained by vowel duration. How much variation in fundamental frequency is explained by vowel duration. Then our slope B1, if positive, it means that our fundamental frequency increases with vowel duration, and if negative, it means that our fundamental frequency decreases with vowel duration. So we have to go back and check our R and check what we have there. Please let's not forget how to interpret this value, because we are going to be applying it there. Going to be applying it. So can you see my house screen?
Yes.
Yes, ma'am.
Okay. Exactly. So now let's look at the R. The R squared and the adjusted R squared. Now, if we convert this 0.1615 to percentage, it means we have 16%. And let us not forget that when we were reading the interpretation that was given to us, it says that the R square value measures how much variation in fundamental frequency is explained. So it means that 60% of the variation in fundamental frequency is just 60% is explained by vowel duration, and that's not good. It seems as if vowel duration is not explaining fundamental frequency well. And if you look at the adjusted R square, you will see 0.05. That's even worse. That's 5%, and that's even worse. So it just like it was raised in the class, it means that the model is not doing well. Vowel duration is not really predicting fundamental frequency. And that also brings us to the p-value as well. And we said the p-value is greater than our level of significance 0.05. And by so doing, it shows that it is not predicting. It is not predicting. So let's go back to our material. Let's go back to our materials. Our time is fast spent. Okay, we've talked about this. Now, application to linguistic data. How can we use correlation and regression? We can use it in phonetics. That means we can use it to check or examine the relationship between articulation rate and intensity. We can use it to check if vowel lengthening affects pitch perception. Then social linguistics, we can use it to check how social demographics affect different variables in linguistic field. For example, how does age predict the use of regional dialect features? There can be other socioeconomic characteristics that you might want to check. Also, psycholinguistic, how can reaction time in lexical decision tasks be predicted by what frequency? I'm sure that we even understand this more than I do, all of these terminologies. So now we have class activity, and it's supposed to be hands-on, but it's a pity. I think we are already even doing it for you. So it's supposed to be an hands-on activity, correlation and regression in R, in which we started in the class. So you have to compute the Pearson correlation between vowel duration and fundamental frequency. We've done that. You have to conduct a linear regression to predict fundamental frequency from vowel duration. We've done that, and we see that it didn't really turn out well. Then you can now interpret your p-value, your R squares, and your regression coefficient. Also visualize your scatter plot with a regression line. The line of code, the R code has been given to us, the script has been given to us on our Google Classroom. So you can download it from there, run the lines line by line. We've tried to explain the lines so that you can get yourself familiarized with what the lines are saying. So get yourself familiarized with it and run it again by yourself. I hope we all have R on our system. Now, before we call it a day, let's look at formulating hypothesis. So a linguistic wants to investigate whether vowel duration influences fundamental frequency. What we did the other time, the hypothesis there. So the research question is there a correlation between vowel duration and fundamental frequency? That's what you did, the correlation we did the other time. Now, the hypothesis will be that there is no correlation. The null hypothesis, don't forget that we have two types of hypothesis. We have the null hypothesis and we have the alternative hypothesis. So the null hypothesis is the hypothesis of no difference. It's just telling you that no, there is no statistical difference. There is no correlation between vowel duration and fundamental frequency. While the alternative hypothesis will be telling you that, oh yes, it exists. There is a relationship, or there is a correlation between the two variables. That's for correlation. When you're doing correlation, you're not really concerned about which is the dependent variable and which is the independent variable. All you are just concerned about is there a relationship between them? Is there something bringing them? Is there something in common? Do they have something in common? And at what direction is the relationship between them going? That's what you are concerned about when you're talking about correlation. But when you're talking about regression, your non-hypothesis is that vowel duration does not predict fundamental frequency. That's what your non-hypothesis is saying. That vowel duration does not predict fundamental frequency. Just like how I think is it Lawan now said that, oh no, it should be the other way around. So vowel duration does not predict non-hypothesis, and then the alternative hypothesis is that vowel duration significantly predicts the fundamental frequency. So when we run the analysis the other time, that's for the first model. I'm not going to do the second model. You can just run it and then you now interpret it. So when we run the first model, okay, so I said that our p-value here was 0.2496, which is greater than 0.05, and it means that we will fail to reject H0. And by so doing, it means you are agreeing to the fact that vowel duration does not predict. Since you are failing to reject H0, it means that you are agreeing with this H0 that says vowel duration does not predict fundamental frequency. So it means that's, at the end of the day, that's the inference we are gaining, we are getting from all of the things that we have been saying since morning. Now, it's not a good predictor of fundamental frequency. So this is the data set in which has been typed out for us in the R script. But in case if you just want to save it, you can. That's the data set. Then this is the output, naturally. But we want you to run it as well and come up with something that you can be proud of, that, oh yes, you did. So this is another one. That's the second model in which I said I was not going to do. So you have to add a second predictor of vowel category to the regression model. And how do you do that? Your linear model in the R script is going to have an additional variable, and that's the vowel. That's plus vowel. Don't forget that your dependent variable comes first, then your set of independent variable follows. So if it's more than 2, it's just going to be plus, 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 and all of that. Then don't forget to put this if you are not putting $sign here initially. So run it and be sure to have something similar to this so that you can know that yes, you are on track. Does anybody want to ask any question? Does anybody want to ask any question? Oh, we are good to go. I'm trying to beat the time so that we can all go. I don't want us to use the 2 hours because of the battery complaints and all of that. So are we saying we understand all that we have said today? Please, if you have questions, now is the time to ask.
I don't have question because I've not been able to practice all this. So possibly when I practice and I
Then you...
face any difficulty, then
Okay.
I'll
Okay,
know.
great, excellent. Kasaba, your hand was up, Nisha.
Yes, ma. I just want to ask if the data we just use is hypothetical, like we just formulate one, or it's real, because what is giving us is kind of correct in real life. And if it is hypothetical and we are getting a real life um, interpretation like
Inference.
inference, yes. So I just want to know if it is hypothetical or just real data, because the result is saying that it's like a real data, like it's
You can
predicting
really relate
what.
with the result.
Yes,
Yeah,
ma'am.
the data set was provided by Prof. So I guess is in the best position to tell us if it was hypothetical or not. Have I answered your question?
Yes, ma'am. Yes, ma'am.
All
So,
right, sir.
Madam, Rawani, can I go on?
Yeah, you have the floor, sir.
Okay, so just like 2-3 minutes, just to add, what you have done today is an example of how you apply statistical learning to linguistics. You know, when you make speeches, it's possible to check the length of your speech, the entire speech. It's also possible to break the speech into different small measures. So, you know, sometimes people talk very fast, people talk slowly, and all that. One brilliant application of this is trying to use the lie detector. So when you watch the frequency of the speech that somebody has made, it is possible to look at the pattern and recognize where there are changes. And when you track those changes, you can now begin to believe that there are things that are happening inside that person that is resulting in a waste of time or a quick response in those areas. Actually, the speech that we make is connected to our brain. So there's no way that you can make a speech without first processing it in your brain. Therefore, if it is possible to connect a device to the human that is, you can read the frequency of the speech, you can watch the pattern of the speech, and then begin to say, okay, at this point, this person is taking so much time to respond. And then when you now compare, it could be when you ask them very sensitive questions and they now take time to respond. You can now begin to make deductions to say, oh, this person is actually telling lies at this point. Moving back to what we have seen today, we have looked at two concepts that can help us to do that analysis. One is correlation. What that one does, like my sisters have said, is that it establishes whether there's a relationship. First, when correlation is zero, then there's no relationship. The closer it is to zero, the closer you can say that there's no relationship. So as it moves away from 0 to 1, or whether positive or negative, that will help you to begin to describe the kind of relationship that exists, whether it is positive or it's the other way around. Because again, people can speak faster when they're actually telling lies. But all you are looking for is a pattern. So you ask random questions, the person answers at a particular frequency or, rate. And then you ask a sensitive question and the rate has changed, whether faster or slower. So when you measure that over a time, you can now say, okay, when you ask this person questions that are really serious, then the person quickly answers. That can also help you. So whether relationship is, direct, that means moving in the same direction, or inverse, is all that you do in correlation. In regression, what you are looking at is which one causes the other. Can A cause B? So you see that they are different. One looks at, is there an existing relationship? If there is, in what direction is it? And by how much is the relationship? But when it comes to regression, you are saying which one is affecting the other, using that word. So when you now get the one that is affecting the other, you can also talk about the magnitude of that effect. So for instance, in your linguistics, you talk about, vowel sounds and consonant sounds. And you know that not all those vowel sounds have the same time frame. For instance, if you write the word P-E-N, which is pen, the vowel sound there is a quick one, pen. But if you now write C-O-U-R-S-E, O-U-R-S-E, with the sound, you see that that one takes longer time. So if you are making a sentence and you are using things like in the course of this discussion, you see now, you said course of this discussion, you are going to definitely take a longer time and you're not going to be able to produce too many words within that time frame. But if you go to another sentence, which is even longer in terms of number of words, but you see that the duration will be faster. Listen to this. The fat cat sat on a mat. You see, longer. But each of them is short as per the words. Fat cat sat on a mat. But so what we are saying in essence is that when you are able to get the first relationship, whether it exists or not, then you are discussing correlation. But when you now begin to ask which one affects the other, then you'll be talking about regression. Thank you.
Okay, thank you very much, sir.
Thank you, sir.
Thank you, sir. That was really good, sir. Thank you, sir.
All right.
Thank you very much.
There are no other questions, or is there any question? So there are no other questions. I think we can call it a day for today. All right. So I hope you enjoy the rest of your evening. Till next class.
All right. Thank you. Bye-bye, everyone.
Thank you, ma. You too, ma. Thank you, sir.
Thank you very much, facilitators. We appreciate, man.
Thank you, ma.